All right. Solving trig equations. Anyone? Okay. So we're going to start with some easy ones. The idea here is you are solving for an angle. We're looking for the angle or angles that make these equations true. Be very careful with the instructions on these problems. There's a couple different ways it can be worded. First of all, it can be asked for either radians or degrees. So you want to be careful with that. And then second, it could be asking for all solutions, which means every solution there could possibly be ever on the planet. Or it could ask for solutions just within a certain interval of numbers. Okay, so you want to just be careful on how you're answering what the instructions are asking for. So here we want all solutions, and we want our answers to radians. So all of our equations, they're called trig equations because they contain a trig function. The easiest thing to do, if you can, is isolate the trig function to start. So like here, how would I get the sine alone? Add 1. Once you isolate it, you can just, if it's a value that's on your unit circle, look at your unit circle to answer the question, which is what most of ours will be. They'll be exact value problems. So where on your unit circle do you have a sine, which is your y coordinate, equal to 1, pi over 2 is the answer. Okay, so that's a solution on our unit circle, but we want all solutions. How often does the sine function repeat? Every 2 pi, every full rotation. So to the end of this, we're going to add plus 2 pi k. Remember doing that before with our functions? What does k represent? K is an integer. So this tells us that every rotation around our unit circle, plus or minus 2 pi, will give us another place where sine is equal to 1 and therefore another solution. Good? Okay. What's the only 2 functions that do not have a period of 2 pi? Tangent and cotangent. Every other function you would add plus 2 pi k, tangent, cotangent, or pi, if you remember doing that. You did learn that at some point. I did teach it to you, I promise.
Oh, no, I believe you.
Okay. All right. So everything's 2 pi except for tangent or cotangent. All right, so this one, the cosine's already alone. You just need to find them on your unit circle. Where is cosine rad 2 over 2?
That's about right. First quadrant.
So quadrant 1.
Pi over 4.
Is there any other place on the unit circle? Also at 7 pi over 4. This is why we're not going to be, if we can avoid it, using inverse functions. Inverse function, number one, if you put this in your calculator, would not tell you exactly pi over 4. It would give you the decimal value of that, which is gross. Second, it would not give you the 7 pi over 4 solution. Yes?
Do you have to keep my radians or?
This one says radians. So yes. So it'll be specific radians or degrees. Okay, how often does the cosine function repeat? What's its period? 2 pi. So to each of these, we're going to add 2 pi k. So both of those represent our set of solutions. Okay. 2 cotangent x minus 2 equals 0. Get cotangent along first. What do? Add 2. Divide by 2. So I have cotangent is 1. How many times on the unit circle does that happen? Let's figure it out.
1 time right there.
Okay, so 2 times it's going to happen. And what are the right there's? Where? Pi over 4 and 5 pi over 4. Cotangent has a period of what?
Pi.
Pi. So to the end of these, we're going to add pi k. Pi k. Now something kind of interesting happens here. Let's say k is 1. If I take pi over 4 and add on 1 pi, where do I end up with? I end up at 5 pi over 4. So these 2 sets of answers are actually equivalent. This is a redundant piece. If you list both of them, I'm not going to take points off because it's the same set of numbers, but you do not need it because that pi takes you to the other solution. Same thing's going to happen with tangent because of where it's period or what is period. Okay? Yep. Okay. All right. Let's say it's not on our unit circle, like 0.7. Okay, it doesn't mean you can't find an answer. It just means that we're going to have to use a calculator, which is why it says here round your solutions. Here it says degree. Okay, so number 1, we're going to need a calculator. Number 2, you're going to need it in degree mode. Okay. Find your calculator. Degree mode. All right. So, if it's not something we can find on our unit circle, we use the calculator to help us evaluate. Now, first of all, before we even touch the calculator, how many places on the unit circle is cosine positive? In what quadrants does that happen? 1 and 4. Okay, so I can kind of go over to the side here and say, I know I'm going to be looking for 2 answers here. I know one of them's in quadrant 1 and one's in quadrant 4 because that's where cosine is positive at. Bless you. I also know I want all solutions, so to whatever my answers are, I'm going to add on what? But I'm in degrees. 360. Okay, so I can kind of set up these answers a little bit to begin with. Okay, calculator. We are forced, because it's not an exact value, to use inverse cosine. Okay, so we're going to do inverse cosine of 0.7. It says round to the nearest tenth, so 1 decimal place. And 40. Are you degree mode?
I'm in radian mode.
Okay. 45.6 degrees we should get. And that's in which quadrant? Quadrant 1. So we have that answer. Now here's the bad thing about inverse functions. Inverse cosine is not defined in quadrant 4, so it's not going to tell us that answer. We have to solve for that answer. Here's how we do it. Again, we know our answers are going to be in 1 and 4. So I'm going to draw my 2 little reference triangles. Because they have the same cosine, they're congruent triangles. This guy, we know the angle, 45.6. This guy is going to have the same reference angle that we already know, 45.6. So to figure out that angle in quadrant 4, we're just going to think of that standard form angle that starts on the x-axis, rotates counterclockwise. We've got to figure out that rotation. How do we do it? Yeah, 360 take away the 45.6. And depending on what quadrant you're in and what function it is, that little calculation at the end can change, which is why the picture is helpful to kind of visualize it. So what is that? 314.4. Now here's the nice thing. This is an equation, so you can check your answer. You can take 314.4, put it back in for x in the original problem, and you'll get approximately 0.7. Okay, so you can make sure you get that piece right. All right, let's try this one. Find, again, all solutions. Tangent x equals -2, and we're rounding to the nearest tenth of a degree. Okay. Inverse tangent, or just tangent, I guess, in general. Tangent's going to be negative in which quadrants? 2 and 4. And to each of those, I'm going to add on what once I find those angles? Pi, but if it's in degrees, 180. Okay. All right. Starting with, again, my problem was tangent x equals -2. How do I get rid of that tangent? Inverse tangent on both sides. You can do that in your calculator. Round to the nearest tenth. It's going to be negative here, right?
Yeah.
Negative 63.4 degrees. What quadrant is that in? It's in quadrant 4. Now here's the nice thing about tangent and cotangent. If I add or subtract 180, I'll actually get the other answer we're looking for. For example, if I take negative 63.4 and add on 180, just 180, what do I get? 116.6. Okay, but again, these are redundant answers. They mean the same group. So you can list either one. If you actually just wanted to stop at this point and list that set of numbers, you could here.
Tangent and cotangent.
That's going to happen every time because we have 2 full periods within one unit circle rotation. Okay. So again, one or the other. If you list both, that's fine. I won't take points up.
So you don't really have to know what quadrant it's in.
Not for tangent, cotangent. No. Okay, let's try this one. 2 cosecant minus 3 equals 0. Okay, here, we don't want all solutions. We only want solutions between 0 and 2 pi. So that's one full rotation on our unit circle. And then we want 4 decimal places. Again, decimal places is going to be a clue you're probably going to have to use your calculator. Okay, so let's start with 2 cosecant x minus 3 equals 0. What can you do first here? Move the 3 over. Then divide by 2. Okay, where is cosecant positive at? Let's set up our answers here. Quadrant 1 and quadrant 2, because it's the same as sine, right? It's its reciprocal value. All right, so x equals, what's going to be the period? Oh, actually, I don't even need to worry about that here, because I didn't want all solutions. I just wanted 0, 2 pi. So we have to do that. Never mind. Okay, so 1 and 2. Do I have 3 over 2 on my unit circle? First of all, no. Do I have inverse cosecant in my calculator? No. So what can we do with this to allow us to take an inverse?
2 over 3.
And
then inverse.
you're going to have to use a sine here. And then inverse sine on both sides. Okay, and it says 4 decimal places. It also said radians. So what degree should you be in, or what mode should you be in? Radian mode. Change it. You're going to have to flip back and forth. Be careful. Okay, so we want, in radian mode, inverse sine of 2/3. 0.7297 radians. Okay, what quadrant is that in, 1 or 2? Well, inverse sine is only defined in which 2 quadrants? Remember that? 1 and 4. So if you remember inverse sine is only in 1 and 4, you know that this is in quadrant 1. If you don't remember that and you're not sure which quadrant it's in, what could you do with that number? You could just convert to degrees, right? Probably the easiest thing to do. And you can actually do this whole problem in degrees if you want, and then at the very end go back and convert to radians if you feel like you're more comfortable doing that calculation. Okay, but that's in quadrant 1 if you're not sure. Okay, still need the answer in quadrant 2. We're going to do the same thing we did before with the reference triangles. Okay? I have an angle in quadrant 1, and this is the angle, 0.7297 radians. Okay? Quadrant 2 is the one I'm looking for. It will have the same reference angle. So I need to calculate from the positive x-axis, rotated counterclockwise. I need to calculate that blue rotation. But we're not in degrees, we're in radians. So it's pi, take away the angle I have. 7297, and that's going to give you your other solution. 2.119. Okay, and again, I don't have to add on the plus 2 pi k at the end of these because we just wanted solutions in a certain interval. It didn't say all solutions. Okay, again, if you don't like the radians, these numbers can get a little gross, convert it to degrees and then convert back at the end. You're just adding 2 extra steps for yourself when you do that. Okay? All right. Next. All right, let's say we try this one now. I think that's pretty much all we're going to need a calculator for. The rest of these will be exact value problems that you can find on the unit circle. Okay, if you see kind of gross angles like this, my suggestion would be to use a little mini substitution. Let theta equal that angle and solve the easier equation first. 2 sine theta plus 1 equals 2. This looks like what we were just doing a minute ago. Okay, so how do I solve for sine? Sine alone. Subtract the 1. Then divide by 2. Sine is a half. That's something that's on my unit circle. How many times on your unit circle does sine equal positive a half? 2 times. There are 2 solutions to this. Theta equals What two angle? Are we in radians or degrees here? Well, it says up there 0 to 2 pi. Right, so it's got to be radians. Okay, so in radians, where do you have a sine of a half?
Pi over 6.
Pi over 6?
And 5 pi over 6.
5 pi over 6. Okay, we're not done though. We had to solve for x. Remember to begin with. We know what theta is. So what can I do now? Yep. Substitute the x back in. We let theta equal x minus pi over 4. X minus pi over 4 equals both pi over 6 and 5 pi over 6. And now how do I solve for x in so many equations? Add pi over 4 to both sides. And in order to do that, you're going to want to think common denominators. What's the common denominator? 12. So you can think of this guy like 2/12 and 3/12, which give me 5/12. And then over here, I can think of it like 10/12 and 3/12, which is giving me 13/12. The problem said we only want solutions between 0 and 2 pi, so we can just stop here. We don't need the plus 2 pi k at the end. Could you check these answers? Yes, we just solved an equation. You have answers. You can plug it back in. As long as you're in radian mode, that would be fine. We can make sure that they both work. Okay? All right. You guys try these two. I'll give you 2 minutes. These ones I want radian answers. All solutions. All right. All right, so get the secant alone, make it a cosine, makes it a little easier to find. Where in radians on your unit circle is cosine negative rad 3 over 2?
7 pi over 6.
Okay, and it's the third quadrant one. What's the other one? Quadrant 2. 5 pi over 6. And then because it wants all solutions, what do I add to the end? 2 pi k. To each of those. This one, if you make it a theta first, you have 2 cosine theta plus rad 2 equals 0. We're going to solve that equation. Get cosine alone. It's negative rad 2 over 2. And the 2 places that happens on your unit circle, again, 2 and 3, 3 pi over 4, and 5 pi over 4. Put back in your x. X plus pi over 3 equals 3 pi over 4. X plus pi over 3 equals 5 pi over 4. And then in both of these, you have to subtract pi over 3. Common denominator is a 12. So let's see, this guy would be 9/12 minus 4/12. So you should have 5/12. Is that right?
Yes.
And then for this one, this would be 15/12 minus 4/12. So 11/12. And then again, we want all solutions, so at the end we add plus 2 pi k. Okay. Questions there? All right. Then let's try, just got 2 more little slides for you. This one. 4 sine squared equals 1. Find all solutions on the interval 0 to 2 pi.
Can you square root it?
So get the sign alone. We're going to use the square root here. Divide by 4. So just keep it exact. 1/4. Square root. Remember, when you're square rooting a fraction, you're going to square root the numerator, square root the denominator. So square root of 1 is 1. Square root of 4, 2. And what goes in front of that? Plus or minus is going to go in front of that, which is something on our unit circle, but now because there's a plus or minus, there's going to be more answers. We're looking for anywhere on the unit circle where the sign is either positive or negative a half. So there's actually going to be 1 answer in each quadrant. where does that happen? Pi over 6, 5 pi over 6, and 11 pi over 6. You notice they're all the over 6s. They all have similar reference angles. Okay. All right, let's try another one. 3 cosecant squared equals 4. 3 cosecant squared equals 4. First step. That's it. So divide by 3. 4/3. Square root. Square root of 4 on top gives me 2. Square root of 3 on the bottom, I'll just leave it. Rad 3 plus or minus. And you can rationalize here, but I wouldn't, because next step is we're going to flip it anyway and make it a sine. So sine plus or minus rad 3 over 2, and now that's what you're looking for on the unit circle, anywhere where you have a sine, y coordinate is positive or negative. So again, there's going to be 4 answers, 1 in each quadrant. And these are going to be all the over 3s. Pi over 3, 2 pi over 3, 4, and 5. Make sense? Okay. Last slide. Find the solutions. Again, we're in radians here, only answers between 0 and 2 pi. Do you see that this is a factored equation for you? You've got 2 binomials, 2 sets of 2 terms, they're multiplied, they're equal to 0. When we do that with quadratics, once it looks like this, how do you solve it? Set them both equal to 0. We're just using zero product property here. If you have something that's kind of in this factored form, you can take each factor, set it equal to 0, and then you get your solutions either way that way. So either sine x minus 1 equals 0, and that makes the whole equation equal 0, or rad 3 tangent plus 1 equals 0, and that would make the whole equation equal 0. So we're just going to solve these pieces individually. And anything that's a solution to either piece is a solution to the whole then. Okay? So sine minus 1 equals 0. That means sine equals positive 1. Where on your unit circle in radians does that occur? Pi over 2. Okay, that's the only answer we're going to get from that chunk. Over here, get the tangent alone. I would have to subtract 1 and divide by rad 3. Again, you can rationalize if you want. I don't think that's going to make it easier here, though. In fact, I would probably leave it and think of this like a y over an x. My y would have to be a half. My x would have to be a rad 3 over 2 for this situation to happen, and then one's positive, one's negative. You just have to remember. So 2 places that happens where tangent is negative. Where? Quadrant 2 and 4. Where in quadrant 2 do we have this situation? 5 pi over 6. And where in quadrant 4? 11 pi over 6. So all 3 of these then, pi over 2, 5 pi over 6, 11 pi over 6 are all solutions to this equation because they make one of the parentheses equal to 0 and therefore make the whole thing equal to 0. Okay? The last one is yours to try. And that's it for the day. Okay, you should have 4 answers to this one, where sine is a half would be pi over 6 and 5 pi over 6. And where cotangent is negative 1 should be 3 pi over 4 and 7 pi over 4. Okay, biggest mistake you can make in these is just forgetting an answer. Okay, if you're not sure, just go look over your answer again, make sure there's not anybody else hanging out there you've lost. Okay, we're going to finish up this lesson tomorrow. There's only like 3 slides left, and then you'll get your take-home quiz tomorrow, too, if you want to get a head start on it. If you're starting on homework, this is my suggested assignment. You can get all the way up through 62. with what we did today. Okay, so if you want to try that on your own, you can. Just a reminder, homework quiz is until next Thursday, so you got about a week to wrap all this stuff up. Take-home quiz you're going to get tomorrow. It will be due on Monday. You'll have a work day Friday. And then tests, we're going to review Monday. It's going to be 2 shortened class periods, Tuesday and Wednesday. Okay? Questions for me? All right, I will do the cell phone lotto. Last few minutes of yours. Let me know if you need anything.